Hello, I told you I would wear my quadratic formula socks for you when we did this lesson, so I suppose this is the next best thing at a question like this. We have a quadratic equation, and if we're trying to find the x-intercepts of that particular equation, we can factor out a -1, and so that leaves us with the following trinomial. If we multiply 1 times -9, we get -9. We're looking for two numbers that multiply to -9 and add to -5. I listed the factors on the side here, and we can see that none of them add to -5. But if you try to graph this on your calculator, you're going to see that there are, in fact, x-intercepts on the graph. So factoring will not always work. Sometimes, especially if you have something with irrational roots, you're going to have to go about getting those roots another way, and that's where the quadratic formula comes into play. This is the quadratic formula in all its beauty. People love using the quadratic formula because it's always going to work. No matter what kind of a question you have, if there are x-intercepts, you can get them using the quadratic formula. It is not, as you can see, the most efficient way of getting those x-intercepts. But if the roots happen to be irrational and you need to give exact values, even if you were to graph it and write down all of the decimal values, those x-intercepts, your calculator screen can only display so many numbers. It's still not going to be exact. So in order to use the quadratic formula, we need to get the quadratic equation into standard form. And then we know a is the number in front of the squared term, b is the number in front of the x term, and c is the constant value. We're going to, once we identify those, substitute them into the various places in your quadratic formula. Let's take a look at an example here. So if I look at the first one, I can see my a value here. So here's my squared term. And because there's no number in front, we know that's a 1. It can't be a 0 or that would be gone. 0 times x squared is just 0. There's also a 1 in front of this term, and my constant is -4. It's not always going to be lined up like this, but the first one happens to be. So the first thing we're going to do is list this. A is 1, b is 1, c is -4. And then if we go back to the quadratic formula, just move this up here so we can see it. We're going to just literally substitute this in. So I'm looking for the value of x, my x-intercepts. We're going to say x equals, so it's a -b. So whatever b happens to be, it's always going to be the opposite sign. So b is +1, but I'm going to have a -1 when I write it down, plus or minus the square root. Now it's really important to put this b in brackets. If it's positive, it won't change the answer, but if it's negative, we're also going to square that negative sign. -4 times the value of a times the value of c. Make sure that your square root covers the entire radicand, and we're going to divide that by 2 times the value of a. All right, once we've got everything substituted in there, we need to simplify it, and we're going to begin by simplifying the radicand. So in your calculator, you can type in exactly what you see underneath that radical sign. I pulled my calculator into the screen here, and what I'm going to do is just type what I see in this radicand in. So I started with the 1 squared in brackets. And then this is a minus, not a negative. So we're going to go -4, and then I'm going to go times 1 times, now this is a negative, so -4 equals. And when we do that, we get 17. So I'm going to go in here and I'm going to write down, okay, we've got equals, -1 plus or minus the square root of 17, and then I'm going to multiply my denominator. So 2 times 1 is 2. And now you're going to take a look at the radicand. This is why we started with the unit radicals. Is there a perfect square in 17 that we can divide out? If there is, you need to divide it out and then simplify. 17 is a prime number. There is no perfect square in there, so we are finished. So there are 2 roots in this particular quadratic. And this plus or minus, what that means, maybe I'll just write this out here, is it means one root is -1 plus the square root of 17 divided by 2. The second root is -1 minus the square root of 17 divided by 2. Now I'm going to write down, these are clearly not going to be exact values, but I'm going to show you what happens. So if we get the value, let's go back to the calculator here. You probably can't see this. I'm just going to slide this out of the way for a second. Okay, so that's what that means, is the -1 plus root 17 over 2 and the -1 minus root 17 over 2. Okay, so now I'm going to type the first one in just so we can get the decimal. So we're going to go -1 plus the square root of 17 equals, because I want to get the entire value of the numerator before I divide by 2. You can also put it in brackets. I'm going to divide it by 2 equals, and then I can see that the value of that intercept is 1.561, and it keeps going. And then if I were to do the second one, so I'm just going to slide this over, I'm going to do the same thing, but I'm going to do the minus. So we're going to have -1 minus the square root of 17 equals. And again, you can put that in brackets if you'd prefer. Divide that by 2. And my second x-intercept has a value of -2.56. So maybe let's just go this way here. So -2.56, and that's going to keep going. So these are not exact values, but those are the x-intercepts. If you were to graph this original quadratic, you will see that these are the x-intercepts you're going to get. One other thing I'm just going to point out here is just remember, roots we know are the x-intercepts. That's what we're looking for. Okay, so moving down to the second example, this one is not necessarily written with the terms lined up as the first one is. So we're going to look for a. We know a is in front of the square term, so a is 4. B is in front of the x term, but as you can see, we don't have an x in this second example, so that means that b is 0, and c is the constant term. So in this case, c is -42. So again, we're going to make a list. So a is 4, b is 0, c is -42. All right, now similar to what we did the first time, we're going to substitute these in. X is -b, and I don't need to put the negative in this case. Well, I guess I can. 0 is neither negative nor positive, but let's just write that down. Plus or minus the square root, and again, b, we're going to put in brackets, squared, minus 4 times the value of a times the value of c, and we're going to divide that by 2 times the value of a. All right, if I add or subtract 0 to anything, it doesn't change the value. So in this case, I'm just going to drop it, and I'm going to have still two values. I'm going to have a positive or negative, and then again, we're going to enter this radicand into our calculator. All right, so I've got my 0 squared in brackets, and again, that's a minus. Minus 4 times 4 times -42, and I want you to try this with me, so you should be practicing punching this into your calculator as well, equals, and now we have a value of 672 as the radicand. And then multiply the denominator, 2 times 4 is 8. Okay, so this means we have a positive root and a negative root, and we're going to simplify. So we're going to say, okay, is there a perfect square that we can divide out of 672, just like we did throughout radicals? And when you go through your perfect squares, again, you can make a list on the top and you're looking for the largest one. We see that 16 is going to divide in to 672 evenly, and that leaves us with 42. So the square root of 16 is 4. So I'm going to put that on top, and that will simplify down to positive or negative 4 times the square root of 42 divided by 8. And now you have to see if you can simplify it. So first thing we're going to make sure is that there's no more perfect squares in the radicand, and then we're going to take a look at our 3 whole numbers. Now normally there's a whole number here, in this case it's 0. So because it's 0, I'm actually going to write that back here. Maybe I'll go back here and put 0 and 2. So you're going to take a look at these 3 whole numbers. I'm going to maybe highlight them here. So we've got a whole number here, we've got a whole number here, and we've got a whole number here. Is there a number that divides evenly into all three of those numbers? If there is, you have to continue on and reduce it. Because of that 0 out front, there's going to be no number that will divide evenly into those. So in this case, our final answer is just positive or negative 4 root 42 divided by 8. And again, you can get the decimal values. If you put those into your calculator, one of them is going to come out to be positive, one of them is going to be negative 3.240. And again, you can always check by graphing. Remember, this is not exact, but you can verify to make sure that you correctly use the quadratic formula and correctly simplified the quadratic formula. I want you to try the last one here. Remember, you're going to put it into standard form first, identify the values for A, B, and C, and then try to substitute them in and correctly simplify. So I want you to actually pause the video, try it, and then once you think you've got the answer, then you can come back and do you have the correct values for A, B, and C? Now, when we put this into the equation, we have a negative b value. A negative times a negative becomes a positive. So whatever the sign is on b, it's always the opposite when it goes in here. I put this in my calculator, and because this is negative, it's really important you put this in brackets when you enter it into your calculator. We are squaring the negative, making it a positive as well. So our radicand comes out to be negative 359. And think back to radicals. What does that tell you? Can we square root a negative number? No, we can't. So this negative tells you, therefore, we have no roots. And then you can check by graphing this. There are going to be no x-intercepts on that graph because we know we cannot square root a negative number. And finally, we're going to take a look at one last example here. And anytime we have a word problem, we know we always set it up with a sketch. So we're going to read the question, and we're going to draw a graph to the side here just so we can visualize what exactly is going on. We're going to label the axes. So in this case, my h is in the place of the y, and we can conclude h is height. And again, compare your units. We've got meters and seconds. Seconds is a unit of time, meters is a unit of height. So I'm going to label this is going to be height in meters, and I'm going to have time in seconds on the x-axis. Let me just slide this over a little bit. Okay, so when we go to draw our parabola, we know that this is in standard form. So this becomes our y-intercept. So I'm just going to put on here, that's 3. And because my a value is negative, we also know that we're opening down. So my parabola is going to go something like that. Okay, so I want to know exactly how long the snowboard is in the air, and that's important because you could always try to graph this, and we know that if the snowboarder starts here, he's going to end here. So we want to get that value. I'm going to go over just with another color so we can see he starts here and he ends here. When you graph it, you can see that you do not get an exact value. So that's your clue. We have to use the quadratic formula. If you don't get a rational number, you also won't be able to factor it. So I'm going to do the same thing. I'm going to say, okay, what is the value of A? What is the value of B? And what is the value of C? And again, put me on pause. I want you to try this. Substitute into the quadratic formula, see if you can get the correct value, and then come back and compare and see if you did it correctly. Okay, so x is now time. So I'm going to put time equals negative b plus or minus b squared minus 4 times a times c, and I'm going to divide that by 2 times the value of a. And again, make sure your fraction line does not cross over the equal sign. It needs to start here and it needs to end here. I'm going to simplify the radicand. So when I enter that value into the calculator, we get 145. 2 times negative 2 is negative 4. Now you're going to check, is there a perfect square in 145 we can divide out? And there isn't. So we're going to take a look at the 3 whole numbers. Now, don't forget, this here is a 1. It's 1 times the square root of 45. So if you look at your 3 whole numbers, this one, and this one. Is there a number that divides evenly into all three of those? If there is, we need to reduce. In this case, there isn't. However, we don't want to leave a negative in the denominator. So I'm going to pull that up top, and we're going to say, okay, if I bring that up top, I'm going to have negative 11 plus or minus the square root of 145. Now we've got it off the bottom. And then if we distribute in here, a negative times a negative is a positive, and a negative times a positive is a negative, and vice versa. So this is still going to be one root is positive, one is negative in front of that root for 145. So there's two solutions, but go back to the graph. This is one x-intercept. This is the other one. We don't want this one because we can't have negative time. So this is the value that we want. So even though we need an exact value, what you may want to do at this point is put them in your calculator just to figure out what is the negative one, what is the positive one. Well, if we have here 11 plus the square root of 145 divided by 4, that's going to be our positive root. So again, if you get the decimal value, it's going to be 5.76. This is just to verify. If you put the second root in, 11 minus the square root of 145 divided by 4, that's going to give us a negative 0.26 ... So this is our extraneous root, which means that this is our exact solution in seconds. All right, so that's the first part of the question. So the snowboarder is in the air 11 plus the square root of 145 divided by 4 seconds. The second one wants to know what is the domain. So going back to what we did a lot of in quadratic functions, we know domain is where the graph lies on the x-axis. We can see that we're starting at a time of 0, and we're going to a time of that value which we just calculated. And again, because they want exact values, I'm going to use that exact number there. So we're going to set this up. And in this case, you can use an x if you want, but I'm going to use a t. So the domain is a set of t such that time is greater than or equal to 0, time is less than or equal to that 11 plus the square root of 145 divided by 4, and time is an element of the real number system. So just to give you a little bit of practice with what we did a lot of in quadratic functions.